Hello, Henry.
Hello.
How's it going?
Good.
Okay, wait a second. Turn on the thing. I think it's been a while. So last time there was do you remember?
Uh-huh.
Was about. Can we go over with that first?
Okay. It's about I.
Yeah, something related to I. Wait a second. Let me. My computer is kind of frozen today. Give me 1 second. Huh? What's happening? Okay. Single here. Where is it? I try to find it. I think. There you go. There you go. It's called 214. Something exercise, something. Wait 1 second. Huh? Okay, that one. That one. Right? Oh, November. Oh, okay. This is actually from general letter. Before that, I believe. Right?
Uh-huh.
A function. Let's start with the first one. What do you have for the first one?
I said 1 plus 2I.
1 plus 2I. Oh, it was something else. 1 plus 2I. So basically, it's asking about fz. Something. I see bar. Okay, that's the important one. So ask fz equals z plus 3. So what is that? 1 plus 2I?
Uh-huh.
Okay. Bar. 1 plus 2I. 3. So 2I. 1 minus 2I. 4 plus 2I. I think okay, good. So let's do it that way. Say, do you have anything saying you feel we need to explain or everything is good?
Yeah, a lot. Well, not a lot. Well, number 7.
Actually, number 7, the problem was wrong. Should have 30. 30 would be, yeah, 20 would not have value, yeah.
Okay. Also, number 2.
Yeah.
Did not get number 2.
Okay, number 2, saying a sequence with zm plus 1, and right here, equals to I times zn over zn bar with with 0 has absolute value 10214 is Okay. Yeah, sometimes this one is frozen. Kind of. It's weird. So Z0, right, has 1. Z2014 is 1. So the question is, what the kind of Z is that thing? How many possible, oh yeah, exactly. How many possible values for the Z0? That's the question you need to answer, right?
Mm-hmm.
So because of this condition, then you can write Z0 essentially is just the angle. So e to the I theta or some theta. Right?
Mm-hmm.
So the question is asking about what kind of theta could be. For example, if theta is 0, looks like good, everything, maybe. I don't know. Oh, let's see together. So Z0 is e to the I theta. Z1 is, just calculate it, is I times Z0 with Z0 bar. So it's going to be I, then Z0, which is EI theta. So Z bar, let's just divide by step by step. Z minus I theta, right?
Okay.
Right? Flip along the x-axis, actually, just Z bar.
Oh, yeah, okay.
So it's I, then E, 2I, theta, right?
Okay.
Z1, Z2 equals I times Z1 e to the I theta, E minus 2I theta. Now become, did I am missing something? I think I'm missing something. Wait. So this I is that I. There's another I here, right?
Uh-huh.
There's another minus I here, right? Huh? Did I, be with me, please?
Okay.
Did I missing something? I think still I, believe it or not. For theta I, I said theta I. Theta I think it should be theta I. It's okay. No, it's theta I said that either way. Okay. So make sure we're right. I e to I. Is that right?
Isn't it minus I?
No, do we have minus y I in the bottom, right?
Uh-huh.
You have, so minus I equal I,
Okay.
because I square is minus 1. Oh, you have minus 1 in the yeah, you're right. So I have the minus 1 in the top. Oh yeah, your minus I directly cancel I. It's minus I. You're right. Okay.
Okay.
We have Z. Keep going. So you can write this one is minus I, then e to the 2 to the 2, and times theta to the I, right?
Uh-huh.
So now it's kind of, as long as going to that model, hard to get back. Huh. That's crazy. I have to click on that thing. Make it work. All right. Okay. We still have I here, have minus I here. Z to the 2, theta I here. Z bar still minus I. Oh, did we? Z bar minus I is plus I here. Okay, this is very important to make that thing correct. Otherwise, the final result will be wrong. Then it's going to be still minus I. I kind of Z to the 3 theta I, right? Always minus I. It's always minus I now, right?
Okay.
So minus I goes to, let's double check. minus I, Z bar minus I is always minus I. Okay, so that is correct, looks like. So in Z to the 2014, it's going to be minus I. Z to the 2014 in theta I. Oh, I'm sorry. We typed something wrong. This is E, not Z, okay? Okay. So this is E. It's easy to make. Okay. So that one equals to 1. Right? It means E to the 2014 theta I equals to I, right? Which is E to the 2 pi I, right? Right?
Okay.
So E and the shoulder can be different from anything like 2 K I. It's all okay. So K is any integer. K can be 0, 1, anything. Okay, so you get 2 to the 2014 theta equals I over 2 plus 2K pi. So K can be anything. K can be from 1 to 3 till what kind of K is going to be going back to give it the same thing. You understand? And then Q is equals to 1 over 2 to the 2014. So K is going to be 1, 2, 3. So if K goes to 2014, then next one is going to repeat 2014. Let's see, 2014. 2014 already repeat. Okay. So 2014 is the same as 1. 2014. No, sorry, 2014 is the same as 0. So 2014 is still okay. So okay, let me explain what I mean. So theta equals to 2 to the 2014, and the theta is plus 1, and the theta equal 1, same thing. Sorry, K equal that. So for k equals to 214 plus 1 and k equals to 1, then we'll give you same theta. You see the difference between saying, okay, let's say it that way. Then theta 1 equals to, or k equal 1 case, so pi over 2. Actually, from 0 is better actually. But even that, theta equal 2 then plus, then 2 pi. Then theta 2 is given by theta 1 is, you have the denominator is 2 to the 1. So theta 1 equals that. Theta 2 equals 2 to the 2014. Then with the k equals that, then pi over 2 plus 2 times k is 2 to the 2014 plus 1. Then plus pi. So look, this theta 2 is going to be equals to theta 1 plus 2 pi. Is that? So the difference between theta 1 and theta 2.
Oh yeah. Okay.
So why in that matter? So you only assume, so you are talking about how many z 0, right?
Uh-huh.
So if another round, so 2 more pi, then means give same 0, right? So you have that many solutions. So totally have 2 to the 214 many solutions. You can say from 1 to 2 to 3 till 2 to the 214, or you can say from 0 to 1, whatever, to the 2014 minus 1. And either way is okay. Right? So the solution, the answer is 2 to the 214.
Okay.
It's a very big number, but let's see. Today, I think it's every time I just forgot to record it. I think that today is I can already say it. How do I say it? Is it recorded? Can you say it? Let me see. Recorded actually, so I can. It's recorded. Okay, so what about number 3 is okay? We need to talk.
Okay. Talk.
Okay, so number 3 is also a little bit tricky. Is I have something in my. Here is the number 3. Z to the 4 minus 4 I, then z to the plus minus 6z squared minus plus 4zi minus square root of 3I equals 0, right? So first off, the very important observation is here. So if you have next name is now, so you expand z. I think it's minus I. Okay, to the 4. It's going to be z to the 4 minus 4I z to the cubic. By the way, do you know that expansion? Let me write it here. So a minus b to the 4, or a to the 4 minus 4 a cubic b plus 6 a squared b squared minus 4 a b cubic plus b to the 4, right? You know this formula, right? Okay, that's good. So then you plus 6 times z square, then I square, then minus 4 times z times I to the cubic, and plus I to the 4, which is 1 actually. Is that right? Don't look right. Z to the 4 minus 4iz cubic minus 6z squared plus 4zi. Okay, so that part essentially is plus 1. Sorry. So if I using the original one, so I put z 4 minus 4iz cubic, then minus 6z squared plus 4zi. The plus 1 is correct. Plus. Then minus 1. Then minus 1. Minus square 3. So original equation, I just add 1 minus 1. Nothing really changed.
Okay.
Right?
Mm-hmm.
And it becomes z minus I to the 4 equals to 1 plus square root of 3i. Right?
Mm-hmm.
So I can write this one as 2 times I half plus I. Right? So that will become cosine, then sine, then is 60 degree. 60 degree. Right?
Mm-hmm.
So I'm able to solve that one. So I have, so z minus I could have 4 different, could possible is 4 square root 2. Then have e to the pi I, this is the one solution, right?
Mm-hmm.
For 2, then have e to the, what is the next solution? So essentially is the root of unity of fourth root unity of 1. So actually it's I, but you can write as e to the 2 pi I and better, right?
Mm-hmm.
It's the second one. Essentially it's I, right? So the third one is
minus I.
you can just minus 1 is okay. I squared, right? Yes.
Okay.
The last one is
Times minus I.
really, if you like, you can write as minus I. So let's, before doing anything, let's say calculate those 4 points. 1, 2, 3, 4. Those 4 points, where are there? Let me join. I'm not sure it's big enough for me to join that thing. So this is how many degrees? It's 15 degrees. So the first one is that one. So 4. Let's call this one called W1, W2. Is that okay?
Okay.
So this is a W1. So you're going to 90 root, so multiply I it's like a 90 degree, right? So here is W2. So multiply another line, get another W3. So then it's W4, right? So the things between W1 and W2, why is this one not working? Oh, very light. No. Okay. It's not really square very well. It should be square very well. It should be a square because, right? The perpendicularity you got there, so every length has so that's a square. Another one, so what is if you call Z1 equal I plus W1? It's just I plus W1, okay? So Z2 will be I plus W2. It's just I plus W2.
Oh, so the whole thing is just up one, or up I.
Up I. We'll see where it goes. So up I, just the first one, up I, probably like this. Sorry, this is not really supposed to be straight, like this. Okay, so W1 is here, then W2 is just another one is here. So just W1 this is Z1, this is Z2, Z1, Z2, and W1, W2 is parallel. So same thing. I don't think that's right. Anyway, so the final picture should look like this. So Z1, Z2, Z3, Z4 is just W1, W2, W3, W4 to move up to the I. It's not really up. Well, move I, right? They're actually concurrent. So the area will be the same. So you only need to calculate W1, W3, W4 the area. So here is the length is fourth root of 2. So the area is going to be either way. You can calculate say W1, W2, which is square plus, then it will be square root of 2 plus square root of 2. Square root will be square root 2 square root of 2. Then multiply together is still, so the final answer is 2 square root of 2.
Okay.
Make sense? Number 4, this is tricky. I'm not sure you get that one. It's actually the gamma, I think the gamma or something, real part or imaginary part has to be 0, I remember.
I don't know. I guess that it was 2, but I don't know.
Guess it's 2. So that, how do I, yeah, I agree. If you've never done that, then it's hard. Plus gamma. So basically, the idea is a function defined. Suppose f1 and fi are real. So f1, fi real. What is the smallest possible value of alpha plus gamma? So the thing is just straightforward. How do you do it? You just assume alpha equals to let's say a plus bi, then gamma equals to c plus di. So a, b, c, d are real numbers, right?
Okay.
So because we are more familiar with the real numbers, so now you say f1 is real, which is 3 plus 2i plus a plus bi plus c plus di is real. So if the real means 2 plus b plus d equals 0.
Okay.
So same thing you say fi. So there don't really want to raise the coefficient, make it bigger. That's pretty small. So 3 plus 2i, then I square, which is a minus 1 plus alpha, which is a plus bi, then z, which is I, plus gamma. Oh, sorry. What is that? C plus di, right?
Mm.
So equals to minus 3 minus 2i plus ai minus b plus c minus di. So it's real. So you have another equation, right?
Mm-hmm.
So minus 2 minus b equal 0. I'm not sure it's right or not. I think it's not right. This is the A. Okay, did you see it? I just typoed something wrong. Did you see it? This should be saying the coefficient of all the I is 0.
Oh yeah. Okay.
So kind of okay, minus 2 should be here's plus A. Right?
Uh-huh.
So we have equation. So we can solve everything in terms of D. So A equals to 2 minus D. B equals to minus 2 minus D. Right?
Mm-hmm.
So now let's calculate alpha plus gamma, which is alpha is square root of plus b square, right? Plus square root of c square plus b square, right?
Okay.
So a square, b square, you get square root of whatever is the a square, b square anyway. So so 2 minus d square plus 2 plus d square. So plus square root of c square plus d square. So the only thing, see, this thing is wants to be minima, so I have to expect c equals 0, d equals 0. Okay?
Okay.
So that one is gradient square root of 2 square, which is 2 square over 2.
Mm.
I just felt like maybe that problem is modified by me somehow. It's not really good. Maybe they have the perfect number at some point, right? So anyway, so next one actually also a little hard. I believe you have problem with it, right? Number 5.
Oh, I thought it was 503.
Oh, you got 500 what? 503 square?
No.
503 square, I think that's the answer.
Oh, I just got 503.
Huh. Interesting. Interesting. So how could, yeah. So the problem saying, as the integer coefficient three distinct positive zero, we have x1, x2, x3 all positive. Then one of them, exactly one of them, x1 equals to x2. Let's say another way. Then x3 equals to x1 plus x2. How many possible value of n is? So this one basically using the symmetric function, using x1 plus x2 plus x3 equal to 1, 4, right? Then you get x3 actually equals to half, so 1007, right? Then you get x1 times x2 times x3 equals to n. Then get x1 times x2 equals to n divided 1007, right? Then you have x1, x2 plus x1, x3 plus x2, x3 equals to m, right? Then you have x1, x2 plus 1007. Then x1 plus x2 is also 1007 equals to n. So you get x1, x2 is an integer, right? X1 times x2 is an integer means n is n over k, then n, this is an integer, right?
Okay.
For some k, we don't know what it is. So now you need to figure out how many k you have. So you have x1 plus x2 equals 1007. So x1 times x2 equals k. So how many possible k you have? Then you have to satisfy some conditions. So x1, x2 has to be positive. Has to be real. What is that? Or what else? Nothing else? Oh, is that right? Right. So that actually x1, x2 satisfies the equation x squared and big X squared minus 1007 the big X, then plus k equals 0, right?
Okay.
So you can have the delta equals to what is it? 107 minus 4 k greater than equal to 0. Greater than 0 cannot be equal to. I think we did something wrong. Did you find out? There is a minus. Okay. So, right?
Okay.
Anyway, doesn't really matter. So actually, this actually has to be positive. K has to be positive here. So, but here is a positive. Right? Okay, so basically k is an integer, the k less than 4/107 square. So we can take k can be equals to 1, can be equals to 2, can be equals to 107 square minus 1 divided by 4. So we know every odd number, the square modulo 8 is 1. So when minus 1 actually divided by 8. So that's that many number. So it's from k or 1 to that. But, right?
Okay.
But delta cannot be a square. Okay? Why is that? If delta is square, if then delta is some kind of square, for it's always squared, I mean a square of integer, right?
Okay. Why?
If delta is some square, you have solved that equation. That two root is going to be 107 plus minus, that's delta square, that's a t square. T square, then divided by 2. Delta cannot be an odd square. Oh, okay. So square is okay, cannot be odd square. Okay. If the odd is square of odd number, then this one is going to be integer. For example, delta equals to 5 square. Okay. Then you can have 107 plus or minus 5. That will be the x1, x2 will be like that, right?
Oh, okay.
So this is the equation satisfied by x1, x2, right? So actually this sentence is not exactly right. So I should say is delta cannot be a square of an odd integer. Okay?
Okay.
So which means we cannot take k such that delta equals to 1 square, 1 square, 3 square, 5 square, till what? Till 1005 square, right? Yeah, right? The maximum x delta is 107 square because integer. So the maximum other square less than delta must be 105 square, right?
Okay.
So delta cannot be 1 square, okay? If it's 1 square, then you get here is 107, and then plus minus 1, then it will be problem, right? Delta cannot be like say 11 square, because if delta is 11 square, then you get this thing, right? Delta cannot be like a 101 square. If 101 square, you get 101 here, right?
Okay.
Delta cannot be 105 square. If you get 105 square, then you get here, actually get the integer root. Where 1 is 1, 1 is something else, right? 1 is 106. That's not good, right?
Okay.
So that's all the numbers you have to remove from this, from the k, which possibly produce those. There are that many numbers can produce some square among those. So how many numbers here? You have, I think it's 503 of them, right?
Yeah.
Right, so the total solution is going to be 107 squared minus 1 divided by 4 minus 503. Right? That's the answer.
Okay.
So you can doing like a little bit 106 times 1008 divided by 4 minus 503. So it is 503 times 504, right?
Oh, well. Okay.
Minus 503, right? So you get 503 out and get 503 left. Type 503 squared. Right?
Okay.
Okay, this one is, how could you get 503? Pretty close. Close to the magic number. Maybe it's just 3 digits. Square 5 and square next into there. So do you get this one?
Which one?
Number 8?
Yes.
Okay. I think I forgot exactly which one is which one. Or what's the difference? What is, oh, it's a 14 something, 13, 14 something. For that one, number 10 is a little bit hard, right?
I didn't get number 10.
Yeah, normal. Actually, when I read the question, I even don't really understand the first time. So let's say you have something. Why is not? Maybe not. See? Okay. So the where's the one? So fx. So dx, then just have so there actually when rotate gx along the point 20, let's say here's 20, 20, 0. Oh, I see. Cannot have this thing to write. So then 20, 0. Among this point, those two curves are symmetric, right? So contains the vertex of graphic. So that things must be one curve can be like that. Another curve has a point. And maybe not. Is that too much? Maybe I just here. And now I just like here. So that would be the F, that would be the G. So the thing is, so here is going to be x1, it's going to be x2, going to be x3, maybe x4. Okay?
Okay.
So you can use flip its top and bottom. Open up, open down is not really a big deal. So x3 minus x2 is 60, which means so it's 30 around. So x3 actually is 50. x2 actually is minus 10, right? Okay, so the line here, John, is not really correct. So that should be around. So somewhere around here is really this is the y-axis. All right. Yeah, no, exactly right. Okay, something like that, right?
Mm-hmm.
Have x3 and like that. So you can assume the x equals to a, x minus 50, x minus b. We don't know what is actually the x1, by the way. Right? Don't need to introduce new variable anymore. So then gx equals to minus f 40 minus x is going to be minus 40 minus x minus 50, 40 minus x minus x1 so equals to minus x plus 10, then x plus x1 minus 40. Wait.
A.
Huh? Is that right?
You need A.
Oh, need A. Sorry. X plus x1 looks like right?
Uh-huh.
So for that one, we need to calculate the vertex. The vertex is going to take A, then x squared minus x1 plus 50, then x, then plus 50x1. So do you still remember the complete square skill? Completing the square.
A little bit.
Then 2, then plus.
Okay.
Square then minus blah blah blah. Anyway, so the key is here is to get A, then x, then minus 2, then x1 plus 50. This is the key. So then plus something. The vertex is, so the vertex here is, yeah, it's obviously because the one is x1 is 50. So 2, then x1, then plus 50, then something. We don't really calculate yet, right?
Okay.
It's the vertex. Okay, now that's actually saying, so whatever here is, we can write here. Here is f. Or lazy, right? The vertex is, the x coordinate is x1 plus 50 divided by 2. The y coordinate is f x1 plus 50 divided by 2, right?
Okay.
So this is the point. If passed by D, Okay, let's put it on G, then you plug into here, you get G right? Right?
Oh, okay.
So let's put it in there to see what happened. So minus 8, then plus 10, then 40 equals to a half of x1 plus 50 minus 50, half of x1 plus 50 minus x1, right?
Okay.
So is something about x1, so you cancel a. Actually really doesn't matter because you see as long as this kind of thing is in there, you can push down, squish a little bit, still work, right?
Oh, yeah.
So still same thing. So this one doesn't really matter. So let's see, we remove denominator 2, okay? So minus 1 plus 70 x1 plus 50 plus 2x1 minus 80. Actually, it's very easy to get the mistake. So this is the x1 minus 50, x1, 50 minus x1. Is that right? Yeah. Right. So we get x1 plus 70. So 3x1 minus 30 equals to x1 minus 50 square, right?
Okay.
Can you solve x1? I will be back in 1 minute.
Okay.
Solve that x1. Hello, Henry. Maybe I typed something wrong here. I'm not sure. What do you get x1 is?
I don't know. I have a quadratic equation though.
Okay, do you work on?
Uh-huh.
Let me see together. Well, I feel the number is pretty weird. Maybe wrong, somewhere wrong. Why does this number look like that? Maybe right. 2100, 2500, 600. One square plus 140, x1 minus 2300. That's what you get. Same thing?
Uh-huh. Yeah.
Same thing as I got?
Uh-huh.
Ah. So get x1 equals to minus 140. Has to be minus actually, because the negative. Okay, divide by 2. Let me write down there. Minus 140. Square root is 196 plus 92, right? So 8.
92. Okay.
288 minus 10 times square root of 288. Square root of 288 is
12 times 2. Right? 144 times 2.
equals to minus 70 minus 60 square root of 2, right?
Uh-huh.
It's the x1. So x4 equals to that one, right? Forty minus x1, right?
Uh-huh.
110 plus 60 square root of 2, right?
Uh-huh.
So the answer for x4 minus x1 is 180 plus 120 square root of 2. So saying ABC, so ABC, that's it, right? A equal 120, B equal 120, B equal to the square root of ABC thing. So that doesn't really matter. That's not important anymore. right? MNP, sorry, MNP, right? So M plus N plus P is 300 O2. And O2? I think it's about right. I remember something like that. Okay, square root 2, definitely right. Maybe we did a little bit wrong, but should be alright. So next time, if you have that kind of question, you probably should be able to solve it, right?
Okay. Yeah.
The confusing part is the hard to imagine what it is. That's what it is.
Mhm.
All right, let's move to the. I think we're done with this. Move to the. I don't have it open. What? Why? Open. There you go. So we have the chapter 12. Did we finish chapter 12 last time?
No.
We're talking about this already, right? Three medians and concurrent, right? I think I remember. Yeah, that's it. Then we look at this kind of pretty magic vector analysis. And I remember I did that with you.
Mm-hmm.
Right?
Mm-hmm.
So three until the concurrent, right? Then we talk about the distance formula, right?
Mm-hmm.
Did we?
I don't think so. I don't remember.
One point to the line. This is only in the plane. In the plane, 1 point to the line. The distance is like that. We didn't talk about this.
No, I don't think so.
Okay, let's see. So there are two ways. First off, the formula is pretty easy to remember, okay? So if you have a line, okay?
Okay.
Then you have a point. So the distance from P, so here's the, let's say here's the line. There's the P. Then the distance is something like that. PQ. So equals to, yeah, I don't have to write that way. I like to write that way. PQ means the distance. Is square root of a square plus b square. Then x0 plus b, y0 plus c. So how do you remember that thing? Remember when the point P is on the line, then the distance is 0, okay? Let's look at an example to see what that really means. Saying, for example, x plus y equals 0, that's one. The line, say, what do you say? Which point? Say 5, 0, for example. It makes it easy. Let's point to there. The distance is going to be square root of 1 square plus 1 square. X0 actually is just 5. It's 5. So is that real? So let's look at it. What happened there? So you have this. So this line basically is that line. So say 1, 2, 3, 4, 5. So what is the distance? This is a special triangle. So this is a 5. So this is definitely the 5 divided by square root of 2. Right?
Well, okay.
That's the formula. So the formula, the proof is very easy. So you can have 2 ways to prove it. Let's prove it for now. So first of all, if you have this is W and this is V, okay? So V dot W, we know that equal absolute value of length of V times length of W times cosine theta. So if you join this right triangle, so V cosine theta just like that. So is, and this is A, this is B, this is C, D. So that just equal AB times W, right? So let's say the distance from here to here, saying this is this is P is here. Okay, here's the thing. Here is how we see it, okay? So this is the line. So where is the direction AB actually is here. So this is the direction AB. The vector AB actually stands for the direction perpendicular to that line. Maybe I join something like this, you'll feel better. Okay, so this is a line. The line is the x plus by equals 0. So this is AB. So N in P, you can think of AB maybe as this way, it doesn't really matter. So any point of P over anywhere, and because here it's messed up, and let's just erase this. Still make P is here anyway. So P is here. So we want to look. We want to see what is the projection of P on P. Wait. Yeah, that's a picture too messed up. Let's get a new picture with it. I remember the book has a very good picture with it. And this line is here. And this is the direction of AB. And you want to, oh, here you go. You want to calculate the distance between the line. So basically, you want to calculate this thing, right? You want to calculate this thing. So assume this is, okay, all right, here we go. So that is the AB. We make, there's no time. Actually, we make the unit vector from this to this direction. The unit vector is a then square root of a squared plus b squared. Unit vector means the length equals to 1. By the way, there is no comment. Square root of a squared plus b squared. Okay. Then we start with any point here. Any point x1, y1. Any point. Doesn't really matter which one. So we connect this vector. So this vector is going to be x 0 minus x1, then y0 minus y1. So this is p still x0, y0. So we want to calculate the things between, essentially we want to calculate this one. How do we do it? Remember, you have this is the O, the P, then this is this unit vector is somewhere, anywhere, and this is N. So we want to calculate between OP dot ON. We remember OP times ON equals to the essentially the distance now. Distance, let's call Q, a different Q, not called R. So OR is the distance from P to the L because here is L, right? So OR times the N, which is 1 already. So it's OR. That's all. So OP dot ON is the distance. So you only need to calculate this. That's all. So OP, we know that is x0 minus x1, y0 minus y1. Dot N dot A, then square root of that, and B square root of that. So that is the distance. That's all. The next thing, you need to simplify it to get OR equals to remember it? So the dot, you get square root of a squared plus b squared. Then x0 minus x1, then a. Then plus y0 minus y. y1, b. Then b. To calculate it, we get so ax0 plus by0. Then minus ax1 minus by1. Then square root of a squared plus b squared. Because x1, y1 is an arbitrary point here, so ax1 plus by1 plus c equals to 0. So this one is minus c, so ax0 plus by0 plus c equals to 1. If you really care about absolute value, that's the absolute value. Okay.
Okay.
There's one way. Actually, there's another way which is not that complicated either. You just doing by brute force. I'm not going to do it, but I point out for you it's not that hard at all. So you have that as ax plus by plus c equals 0. Then you have p x0, y0 here. So through p, you make this line. So this line, you know this line has a slope is y equal b over a then minus a over b. This is the slope. So you have y minus y0 equal minus b, then x minus x0 is this line. Okay, now let me different color. So that's line, right?
Mm-hmm.
Now you have this line, you have this line. Then you can solve the intersection point. All right? So it could be x2, y2. That's easy to solve, right?
Mm-hmm.
And once you get x2, y2, x0, y0, you can get d equals square root of then you can calculate. By the end, the result is pretty nice, actually. Okay. So do you want to go to detail, or you want just accept it?
Okay, next.
I have to close this. But somehow, let's see, it doesn't really work very well. Oh, okay, it was here. Actually, the next several slide was just trying to explain that formula. This given line, the AB is a normal vector direction. So yeah, the reason is if you have 2 points, x1, y1, x2, y2 on this line, you will see the vector formed by from x1, y1 to x2, y2, which is x1 minus x2, y1 minus 2, which is the second part of that thing. So which is perpendicular to AB. So this is the line direction, you see it? So x1 minus x2, y1 minus 2, this vector is the direction of the line.
Oh, okay.
Yeah, just 2 points on the line, right?
Mm-hmm.
So AB is the direction which is perpendicular to the line. That's why we call AB is a normal vector, A space B. AB, form the vector.
Mm-hmm.
Okay. So, that's why. Okay, let me just see the formal written way. So assume the distance from P to the line L. That any point Q on the line consists the normal vector QR AB. Then we have QP equals to Q equal to QP times QR equal to D. So just to solve it, then get it. Same thing as I explained over there.
Mm-hmm.
A little typo here now. There is a space missing space in the middle. Okay. Anyway, let's see next thing. It has been a while. So the area of have we learned the cross product? Did we? Did I tell you what so we learned dot product, that's for sure, right?
Yeah.
So so my question to you, did we learn what the cross product is? I think we did. Also, I'm trying to explain to you with the right hand system.
Is that the thing that's only in 3D or
Yeah.
something like that?
Yes, only 3D. Only in 3D, that's right. Okay?
Okay.
But so only in 3D, but we're talking about something in 2D now. So see what happens. So what happens between the 2D and the 3D, okay? So if we have the two vector AB, like give an example. We have two vector AB. One is One is like saying, let's say make this simple, okay? One is 5, 0. There is no comment between. One is 5, 0. Another one, let's make 3, 3. Okay? Two vector. So we want to calculate the area formed by them. So actually, I just learned the trick. You can join the line. This. Say 1, 2, 3, 4, 5 here. We have 3, 3. So 1, 2, 3, 3. That's about here. So we want to calculate the parallelogram formed by this, okay? This is in a 2 dimension, by the way. So how do we using that thing? Then we make 3, 3, 0, and 5, 0, 0. These two vector in the 3-dimensional space. Okay, it's something, one is here, and one is there. Then, so the length of this curve, 5, 0, 0, is the area of that parallelogram. Okay, that's the definition, right? So we just add one more direction or dimension to the two vectors, then we create that one. So 3, 3, 0, cross 5, 0, 0. So do you remember how to calculate this one? So the first one, see, it's 0. Second one is also 0. The last one is, that one times that one is 0, that one times 0 minus 15. So this actually is going to be the area. The area is a minus 15? Huh? Serious? Yes. Yes, definitely serious. Because this is 3. This is the 5. This is the paragraph. Yeah, it's 15, okay? You got it? So the cross product is 3-dimensional thing, okay? It's only 3-dimensional only thing, right? Then we come to like 2-dimensional. How do we do it? So we just add one more dimension. Then we consider 2-dimensional vectors as 3-dimensional thing. That's all. So the same thing will apply to like say 4-dimension, 5-dimension. So how do you do it? Then you in the 4-dimensional space, if you have 2 vectors, okay? Assume the 2 vector, whatever. Anyway, then you can move them to like one plane. Assume they're one plane. You just vector can be moved parallelly. Assume you move those 2 vectors all pass from the origin. Okay, it's okay, right? You got it. So then you can form a 2-dimensional thing, essentially. So essentially, you consider about the third vector, which is the cross product of those 2 vectors, is in the 3-dimensional form by those 3 vectors. So A, B, and A cross B. So anyway, so this is the formula different. So that's it about the okay. Let's see what we're doing here. The length of the vector AB, the area of parallelogram formed by AB. Okay, 2-dimension, 3-dimension. So for giving vector ABC, So the value A dot B times cross C is called the cross product, no box product. Okay, it's just the name. It's not as important as dot product, not as important as the cross product. So box product is something you don't have to know. It's nice to know, but the dot product and the vector and the cross product is something you have to know. So it's the volume of the paragram formed by ABC. So that one actually is pretty straightforward. That's that one, A dot B dot C. Not sure you still. Do you want to say why in this one?
Okay.
Oh, I'll accept it. Oops.
Whatever.
What is that? What are you trying to do that? Yeah, okay. I only have, saying that way. Let's say you accept for now. Let's do an example to see what that really means, okay? So next time we prove about it. So first thing for next time we prove this box product. Okay.
Pretty easy, right?
Very easy because by the definition, so A is just x1, x2, x3, x1, y1, z1, right? Then B cross C. You know what the B cross C is? So the first one is y2, z3 minus z2, y3. Remember?
Oh yeah.
So this is like saying x1, that thing. So it's very easy, very easy. So now let's go to say find the volume of the tangent with the vertex at that 4 point. That is something you definitely need to know. Giving 4 points in the space to find the tangent formed by that 4 point. Okay. So how do we do it? Actually is pretty easy. I think I need to close it. So you have 1 point. Then they have thing have space link. I have no. I have found 4.1, 2, 3, 4. Okay, I have 4 points. So how do you find the tangent formed by those 4 points? Why not doing that? Sometimes doing. Okay. So you have you can do it easily. Just move any point to origin. Okay. Move this point to origin. Then this point is going to be so 231 minus is going to be 133. So another point is going to be 1 minus 2. Another point is going to be minus 2, 2, 1. Now actually you're asking about those 3 vectors. Those 3 vectors is going to form a a paralleloid, parallelogram. What is that thing called? Do we give it a name? Parallelogram. Parallelogram solid. Okay. So it's going to be parallelogram solid. So will be like this. Okay, it's parallelogram solid, whatever we choose to form. Let's form this way. So form that way. Form that way, then you're going up. Then you're going up. Then you're going. Actually, this one goes to here. Going up. Oh. Okay. So that will be the parallelogram solid. So the things that titanium only is so what the difference between the volume of the parallelogram solid and the titanium? T and P, the relationship is the volume. Is 1/6.
Is the top of the tetrahedron also the top of the parallelogram?
Yeah.
Oh, so it's like half of the pyramid, right?
Not half actually. Yeah, it depends on what you think half. So actually, the bottom is half. Okay. Bottom is half.
Yeah, because if you have a pyramid, it's like 1/3 of it, right?
Yeah.
So then this is like the half of the pyramid.
Actually, the things that I joined probably not already right. Actually, probably okay. Yeah. You see the picture over there? So the bottom, the area is half. Okay. Then yes, using the formula, the totally the volume of the pyramid is 1/3 of the base times the height, right? So the base is only 1/2 of the whole parallelogram thing. So it's P times H. So totally is 1/3 of everything. Okay.
Okay.
So that's going to be 133. 1, 1 minus 2, minus 2, 2, 1. So that will be the final answer with it. So whatever it is, the answer is like 26/6. Okay. Ha. That hard to imagine it. Imagine about it. Hard to think.
Not really.
Yeah, not really actually. So I think probably today we're going to end with this. So that probably is very, very simple. Just a definition. So next thing we're going to talk about three-dimensional polar coordinate. So I will still send you another set of problem. Okay.
Okay.
This time probably more involved with geometry. Actually, you are doing geometry pretty well, but lot of people saying the geometry actually is a hard one when doing the MC test. So I will send you another set of problems. So you will work on, then we talk about next time. Okay?
Okay.
Okay, thank you. Bye.
Okay, bye.